7.4 Day 3, we're looking at complex fractions. A complex fraction is a fraction that contains a fraction in its numerator or denominator, or sometimes both. A complex fraction can be simplified using either of the methods below. So method 1 is, if necessary, simplify the numerator and denominator by writing each as a single fraction, then divide by multiplying the numerator by the reciprocal of the denominator. Method 2, we're going to multiply the numerator and denominator by the LCD of every fraction in the numerator and denominator, and then simplify. So I'll show you both methods with the same problem so you can kind of see what that looks like. And each method is good. It's just a matter of what type of fraction you have. And so you'll see that in another example. So for this first example, we're going to use method 1. We're going to add the fractions in the denominator first and then divide out the common factors and simplify. So in order to add the denominator, so let's focus on here. In order to add them, we have to have a common denominator. So notice what we have here is an x plus 4, and then we also have an x. So on the right side, we need to multiply by x plus 4, so we have a common denominator so we can add them. On the left side, it's missing just an x, so we multiply an x on this side, so that way it's the same. So on the top, let's just rewrite this top value, and I'm just going to leave it alone for now, 5 over x plus 4. And then we're looking at the denominator here. So x times 1, that's just x. And then plus 2 times x plus 4. And then all over the common denominator of x times x plus 4, right? They're the same because we multiply by it, so we can just put it under the same fraction there. So now what we're going to do is let's distribute this 2x, the 2 to the x and the 4. And so now let's take a look at it. We have 5 over x plus 4. And then we have x plus 2x plus 8 all over that common denominator of x times x plus 4. Now, what we're going to do now is we're going to multiply by the reciprocal. So let's just rewrite this. We have 5 over x plus 4. And then this division bar here, so this one in particular, that means we're dividing by whatever in the bottom. And so let's combine like terms first. X plus 2x, that's going to be a 3x on top. So 3x plus 8 all over x times x plus 4. Okay, so I simplified that. So I hope you see that here. We distributed here, and we get this, the x plus 2x plus 8, and then 2x plus x is 3x plus 8. So now when we're dividing by a fraction, remember that we multiply by the reciprocal. So now this is 5 over x plus 4, and then we're going to multiply now by the reciprocal. So we're going to move this, flip it. Now we're looking at x times x plus 4 all over 3x plus 8. So now what we want to do is evaluate whether or not we have things we can cancel out. And we do. We have the x plus 4 that can cancel out. So now we have what's left, 5 times x and the 3x plus 8. So this is 5x over 3x plus 8. And so now this is simplified. You can't have a complex fraction. So that means no fractions in the numerator denominator. Now we do need to take a look at our restrictions. Now with our restrictions, we want to go all the way back to the original problem. So looking at our original problem here, I want you to notice that we have x plus 4 here in the denominator. We also have x plus 4 and x in the denominator here. So what makes this 0? So we can say x plus 4 cannot equal 0. And then also this here, this x cannot equal 0. And so we subtract 4 for this side. So we know that our restriction, one of them is x cannot equal -4. And then the other one is x cannot equal 0. Then we could name this one as well. We know that if you solve for this, it would be -8 over 3. Okay, so it's really important that you do write your restrictions, what are you not allowed to have, after you simplify. So this is a complete answer. Now let's try method 2. We're going to multiply the LCD of all the fractions in the numerator and denominator, and then we're going to multiply that to every single term. So I'm going to rewrite this problem. It's 5 over x plus 4 all over 1 over x plus 4 plus 2 over x. So the LCD, we're going to take a look at every single denominator in this problem. And so when we're looking at it, we're looking at the x plus 4, the x, and the x plus 4. So notice it's quite similar to the problem above. So our LCD is x and the x plus 4. So I'm going to multiply that to the numerator and the denominator. And it looks like this. Now really what's happening is this x times x plus 4 is getting multiplied to every single term. So let me write that out so you can see what that looks like. So we have our 5 over the x plus 4. And so we're going to multiply this x times x plus 4 to the numerator. And that's really over 1, so that's why I'm writing it in the numerator space. Then in the denominator, I have 1 over x plus 4, and then I have the plus 2 over x. So again, I'm taking this x times x plus 4, multiplying it to this term here, and I'm also multiplying it to this term on the right as well. And so that's what's happening when I multiply the LCD to both the numerator and the denominator. So notice, look what happens when we do that, is that now I have this x plus 4 here, that cancels out, and then on the denominator here, the x plus 4 cancels out, and then on the right, we have the x that cancels out. So notice what we're left over. We have the 5x here, there's nothing in the denominator, and then here we have the x times 1, and then we have the 2 times x plus 4. That's all that's left because all the denominators are now 0. So that's what's really nice about this, is that it cancels it out and we're only left with a regular fraction. So let's write what's left over so you can kind of see it. So this is 5 times x is in the numerator. Then in the denominator we have x plus 2 times x plus 4. Now we go ahead and distribute this 2 to the x plus 4. And so I'm hoping you're seeing that this is very similar to the other problem. And so we have x plus 2 times x is 2x, and then 2 times 4 is a positive 8. Let's simplify this. So this is 5x, and then x plus 2x is a 3x plus 8. So sometimes using this method is a lot faster. And notice here is our final answer. Now again, we take a look at our restrictions. We cannot have 0 in any of the denominators, and it's always good to go back to the original. So we know that x cannot equal 0, and x cannot equal negative 4. And we could name this one as well, that x cannot equal negative 8 over 3. Okay? If you have a hard time seeing that, again, you do 3x plus 8 equals 0, cannot equal 0, and then you solve for x. And that's how you get x cannot equal negative 8 over 3. So let me try one more example. Number 10. We have x over 6 minus x over 3 and x over 5 minus 7 over 10. Now in this case, I would say because there are 4 different denominators, there's a lot of them, we could use method 1 because method 1 is the nicest. Because that way we're not finding the LCD for all 4 of these denominators. We're only having to deal with the numerator and then dealing with our denominator separately. So in this case, let's deal with our numerator first. We have 6 and 3. We notice if I multiply 2 to the right side, then 3 times 2 is 6, and then that's common. Now in the denominator here, this 5 and 10 is close, so all I have to do is multiply by 2 over 2 to get a common denominator. So let's go ahead and write this out. We have x over 6 minus, then this is 2x over the common denominator of 6. And then in the denominator here, we have 2 times x all over 2 times 5, which is 10. And then minus a 7 over 10. So notice this is a lot nicer. So let's go ahead and finish this out. X minus 2x is a negative x over the common denominator of 6. Then this is 2x minus 7 all over 10. And then, so remember, let's write this negative x over 6 divided by 2x minus 7 over 10. So that means we flip and multiply. And when we can, let's reduce. So we notice that we have 6. 6 can be rewritten as 2 times 3. And 10 can be rewritten as 2 times 5. And so we notice that the 2's can cancel here. So this is, the answer is negative 5x all over 3 times 2x minus 7. And then here we can see our restrictions here. We know that x cannot equal positive 7 over 2. And then looking at this here, they're just numbers, so we have nothing else to name there. So please finish out these 3 problems here only, 1, 2, 3, 11, 12, and 13 as extra practice. You don't have to worry about these problems for now.